Hey everyone, so we will solve 1461. Check if a string contains all binary codes of size k. Now, um, just to begin with, right? When you really think about this um, question, let's just read through this, right? So you're given a binary string s and an integer k, and you have to return true if every binary code of length k is a substring of s, right? Otherwise, return false. Okay. So let's write some facts about this, right? Return type is boolean. Okay. Now you're given a binary string of s. Okay. So your binary strings are nothing but 0 1, right? An integer k, right? Now when do you return true? If every binary code of length k is the substring of s, right? Else false. There you go. Okay, so that's your condition over here, right? Now let's go through some examples, right? You have your s as 0, right? You have this. So now if you really look at it, if you look at the explanation, or rather let me just do something. So you're given a length of k, right? Your binary code of length of 2. So it could be 0 0, right? It could be 0 1, it could be 1 1, it could be 1 0. That's about it, right? So what if it was k is equal to 1? So what are the types of binary code that you can make? 0 and 1, right? I think that makes sense. K is equal to 2. This is the thing. Now for example, if k is 3, what do you think the would be? Right, like 0 0 0 1, 0 1 0 1 0 0. Then you have 0 1 1, and then you have 1 1 0, right? And at the end you have 1 1 1. So there's 4. That's 1 2 3 4 5 6 7. Okay, there's one more missing. There's 1 1 0 1 1 1 0 1 1 0 1 0 0 triple 0. Okay, you have your 0 1 1, right? Yeah, you have your triple 1, you have your 100, you have your 1 0 1. Okay, so yeah, 1 0 1 was missing. So you have your 1 0 1. There you go. So if you look at the basic pattern or any mathematical thing, right, you would realize that yeah, it's just basically 2 power key is the number of combination that you can make, right? So that's 8 and so on and so forth, right? So now if you really look at it, what's this doing is, does all of these 4 things are in the string or not, right? So let's do a dry run, right? You 0 0 1 1 0 1 1 0, right? Let's do a dry run. You start from here, right? You say, as a smart person, you would probably use sliding window technique, at least according to me. This makes sense, but let's see what happens. Of k size, right? So that means you have your first window. So does this window contain one of the number, one of the combination in set? Okay, yeah, it does. 0 0 exists. Okay, cool. Now you move forward and then you do this. Okay, so now here one more. Does this exist? Yeah. Now you do one more thing. You go here. Same thing here. 0 1, does it exist? Yep. And last but not the least, 1 0. Boom. Now all of them exist, so return true. But if they didn't, if however this was 1 1, for example, now yes, it does exist, but did we get the last part? That is your, I think 1 0. Yeah, this is left over. So no, it doesn't. So this would have become false. Um, so yeah, these are your types of things that could possibly go wrong. So if I were to create a hypothesis, rather, right? Um, Not hypothesis, or possibly algo, right? How am I gonna solve it? So for me, create the combination set is the first step. Second step is to loop through string with sliding key window and make sure all the elements in set are used. In fact, we don't need set actually. Um, we could just use simple list. Yeah, that's better. And then of all the things, if one or more is left, return false. That's one condition. This is the exit condition, right? This will be at last. If element doesn't exist in set, doesn't exist in list, return false again. That's alright. And else true. There you go. Okay. Yeah, that's my entire idea behind it. So let me just put this up here. Okay, so now one thing you have to know is how to make combination list. Well, there's backtracker, right? Or maybe, I mean, backtracking also enough. So how do you do backtracking again, right? So you will have possible combination of ones and zeros, right? So you go like, hey, definition of creator, right? Choose equals to creator plus one, or you choose one. Yep, choose the creator 0. And what's the base condition of this? Let's see. If length of, you know, string combination, so length of combination is greater than or equal to k, boom, you return. You just add it to the list. So combination list dot append, combination itself, and you pulled, or rather you just return a string. So once it returns, right, so it will start with empty string, it will become, you know, plus one, so at the end it will become one, and then yeah, that's creator, right? Okay, now yeah, this is better. It is n equal to k, and so combination plus one, that's it, plus 0. There you go. Okay, once this is done, we'll just keep returning. So let's do some dry run, right? Let's start with creator of empty substring. Now what happens, right? Let's put k as, let's put k as 2, right? So what is it gonna do? That's the question. Now I'll go for choose one, so that will become basically creator will become 1 and your length is 2. So now we are inside the choose one creator. Now is length of combination greater than equal to k? Nope. So you again, you can choose either one. So your creator now has 1 1, and this will return, this will basically add up the adds length to list. Okay, that's one. Now you come back, right? You still have 1. Now you choose 0 on that, right? mm. 0, you have 2. Okay, then you add it adds 10 to the list, and then you come back. Now you choose a 0 over here, which makes the creator have 0, and two. Same thing, choose one, blah blah blah, and then at the end you will get a list. Okay, good enough for me. And one thing that I'll improve over here is not assign any variable. That makes no sense also. Yeah, that's about it. This is your dry run, by the way. Yeah. So I solved one of the problem. Right, let's create a function that helps us out for this. Definition of creator, um, com and then key. I wouldn't honestly care about it because this is Python, so I don't have to do it. But if you have to, yeah, you can use. You should possibly use key in C++ or in Java. So now let's see where this goes. If length of com is greater than or equal to 2, you can just add list to the end. So that would be com list dot append com. Of course. Sorry, this will become k. Yeah. Otherwise, you create a creator, and then com1 is the name of com plus 1, com1 here. And then you do com2, create com plus 2, right? And then you create com2, and yeah, that's about it. Let's create all the list. Yeah, I would hope so. Your K is here, S is here, right? Now we'll definitely call creator with an empty string, and this should do it. Now we need a way to definition chapel. Right. Now what does this do? Case size starting window. Okay, awesome. So let's see. Now you have your case size sliding window, so k is equal to 2 and so on and so forth. So your start would always start with 0. Your yeah, I mean your end would be, I think, start plus k. Okay. Don't mind me because I haven't done DS in 6 months, so I'm just trying to rebuild everything, and as a whole I've never done DSA properly in my life, so that's one more thing. So your while end is okay. So one more condition that I just noticed would help us out to cut it immediately is creating a base condition. If length of s is particulars as length of s, right? If length is less than equal to no, length percent k is not equal to 0, then you return false immediately. There you go. Why? Because let's say you had 0 1 1 0 1, right? It'll never work. It just would not work. So yeah, that's your early return. Early return base check. Okay, let's going back to this. While end is less than equal to length, right? What it needs to do is start plus k. Now let's see. All right. So there's a string. Let's say if we can't do equal to, we do less than. Why? Because let's say you come over here, right, and you get 1 and 0, so the 0 becomes a problematic thing, right? Okay, so until and unless end is less than length, we should be fine. So this is one good thing. Now we have to start checking, right? So we have to say if s of start end, right, in com list, right? You can put your com list here. And in com list, then I think we can just pop the com list, right? So we could do com list dot remove whatever the binary equal to okay, so this will remove the binary. Now what else was the logic for? Let's go back up and check the logic that we created. Okay, loop with string, make sure all the elements list are used. Okay, if element doesn't exist in this, return false, right? Okay, so that's our return condition. So put else and yeah, return false, right? Once everything is done, okay, so now we have to do one thing. We have to put start as, you know, plus equals to k, start as end plus 1, or wait, so k is 2 over here, there'll be 0, 0 to 0 plus 2, there'll be 0 and 1, right? So end is 1, so end is 2, but it'll count till 2, start will be 2. Okay, so I don't need plus 1, and end will be plus equal to k. Yeah, that's about it. Once everything is done, so I made checker, put away, let it run. Now lastly, I'll have to just check if com list when the com list is equal to 0, return true, else return false. There you go, and we have done it. Okay, so we have a checker, we have a creator which creates the combinations, okay, We have a length percent k condition, that is the early exit condition. Do we have the base condition here? Then length of comb is greater than equal to k. Okay, fair enough. So yeah, this should do it. Let's see. Okay. Well, memory limit has been exceeded. That's okay. Why though? Length of comb is greater than equal to k. Equal to k. Okay. Why would the memory limit exceed? Is my only question at this point. And the string is we have put this. This shouldn't cause any problems, right? Like, I don't think so. It would cause any problem whatsoever. So you get as a start of end. This is correct. So I think this is probably the only reason why it's failing. Let's see. Okay. So can I use hint one? Yeah, I mean this is correct. Then what's the problem with why am I getting memory limit exceed? I mean, what do you do with this thing? Just looking at it. So let's see once. Comb of 1, comb plus 1, greater goes there. Comb of 2. I mean, oh shit. Oh shit. God, I'm an idiot. Ish. Okay, so you do 0 0, and then you do 1 1, and then you do 0 1. I mean, instead of distracting, what if we keep adding, right? Like, what if, just what if I do this? Let's see. Like, there is 0 0 that's added, 1 1 that's added, there's 1 0 that's added, so, there's 0 1 that's added, and there's 1 0 that's again added. So this is 2 power k, right? Now same thing for 0 is added, 1 is added, 1 and 0 is already been added, so we can ignore it as long as this 2 power k, right? The same thing over here, 0 on the side, 1 0 is added. But is it 2 power k? No. Fails. Okay. Let's just try this out once, right? So here your lens has length of s, right? Let's see. New form would be on set, right? Then I think what I can do is I in range lens will be the entire string, right? Yeah. If I look at the entire string, right, then 0 0 0, I come over here. Wait. What I wanna do is basically just keep adding each substring. We'll have k plus k thing, so we need k plus 1. Okay. Okay. You add new comb, and then you just do s. So do I as I plus k, right? Is 0 plus 2, so that'll be 0 and 1, right? Okay, fair enough. Now all I have to do is just check if length of new phone is equal to the power of k. Now one thing that's very obvious to me is if n less than k, just return false to. I think that should do it all. Let's try it now. Oops. That has been a shitty indentations, my god. Right, that'll be length of string, not 10. Yeah. Okay. Okay. Amazing. I don't think, I don't know, this has a surface level of easiness to it, but yeah, it just gets worse over time. I mean, I knew it's lighting windows a thing. That was very obvious. What was I into? I mean, dude, I figured it out long back. I did this, but I did a stupid mistake of, you know, doing a complicated method of, finding out all the combination and other things. I would have not been able to do that otherwise. Like, I for one, I don't know. Like, I figured it out, but the problem was the entire problematic part. But okay. So yeah. What the hell is this? On top of okay. Oh my god, just people have some sauce. They think they're cool by doing such stupidly complicated code for no reason. Rolling hash. Okay, that's an over exaggeration, but okay. I see why. Okay. Did mask of whatever, and then what has this person done? Okay, here's the edge blah blah blah. I mean, yeah, this is a good binary. So this is an example that could work. Oh, oh, I did not know that was a base 1002. I don't think that's possible. Okay, yeah, exactly. Bye. But yeah, pretty interesting solution. But this is something that I've never done, so I'll be doing bits manipulation in the coming videos. So let's see what goes.